All right, welcome everybody to the March 14th AWX Community Meeting. On today's agenda, we have the following. We're going to start with the Spud Award, and then we're going to talk about scaling and Redis caching if Manny is here. And then we're going to talk about SAML from extra settings if Nick is here. We then have a special presentation from Crunchy Data. And then we're going to do some contributor things. And then the remaining time is going to be open for general discussion. And with that, I will kick it over to Al for the Spud Award.
All right. Thank you, John. Can everyone hear me?
Yeah.
All right. So this week's Spud Award goes to Stanislav. I'm not going to try to pronounce the last name. I'm sorry. Thank you for your contribution. We learned from every single one of your PR. And just to highlight his most recent contribution, he added code to allow us to gracefully terminate instance of AWX so that eventually we will be able to do graceful rolling upgrade of the Kubernetes cluster underneath the AWX. So thank you for your contribution. You will be receiving Angry Spud in the mail. That's it. Oh, before we roll to our next topic, John. So apology for anyone that's watching that intended to attend this meeting. We had a little bit of we had a little bit of problem handling the time change. So I understand that our meeting is typically scheduled at 1500 UTC, but we actually sent out the meeting invite based on EST, so it changed. Apologies. We will address that from now on.
Good call out, Hal. So Nick, are you here?
Yeah, I'm here. A while ago, I was configuring the AWX operator via Helm configuration, and I got stuck implementing the SAML parameters in the extra settings fields. So I was wondering if there was some kind of guide or further explanation on it.
Christian, you want to try to address that?
Yeah, sure. Right now, I think all we have as far as docs is the bit in the README about it, which I can link to. But I know that other people have had issues with quotes on those settings. I'll see if I can dig up one or two issues where I think maybe John or Seth had some useful comments on there. Do you know in particular what issue you're running into, like what the error is?
It was a while ago, so I vaguely remember. But I think the main thing was that the settings just didn't pop up in the interface, in the web interface.
Okay. Yeah. So I can just kind of go through how I would start to debug that too. So what it sounds like what's happening is that the syntax was probably not right enough for the Kubernetes like CRD validator. So it probably just got kicked out by the validator. So like the first thing to check when debugging that is to see that it actually got set on the resulting AWX custom resource. And if it didn't, then then the issue is before then in the YAML syntax. And I'll point to some examples of at least valid syntax. But I know that it probably doesn't include all the settings that you may want to configure in this example.
I will also say with SAML, it can be a little bit more difficult. It's not quite as straightforward as LDAP because you have to know things like the route and the endpoints ahead of time. So Christian, you can correct me if I'm wrong. I think for SAML, I thought we were going to lean towards that kind of being more like a day one activity where you configure that post deployment of the operator.
Yeah, that's right, because you don't know the host name ahead of time. Yeah, I mean, it's still so, as far as how to specify settings for any of these things for like SAML or LDAP, like it's all controller or AWX settings. So it's all settings you can specify under the extra underscore settings parameter in the AWX spec. So I have a link to the docs, README docs for that.
Yeah.
And so you can hypothetically pass it if you know what host to expect. But like John's saying, like there's not a good way for us to, point people towards, knowing like how to check to know what the host name will be.
Yeah, for your information, when I set the settings via the GUI, it does work. So I can get SAML working. So it's just via the extra settings that it fails.
Okay, gotcha. Yeah, this is a great question, and if you don't already have a issue for this, if you can make one, that'd be good. Because then we could continue conversation there, and hopefully come to some way that we can, make it possible to configure this as a day one thing, or
Yes.
if not, have good documentation around, how to get it going for day two.
Good. I'll create that issue later on.
Sounds good. Thank you.
Thank you too.
All right. Next up, we have our friends from Crunchy Data. If whoever's going to be presenting, feel free to take over the screen share.
So thank you all for taking the time today to join us for this presentation. My name is Patrick McLaughlin from Crunchy Data. I'm a data solution architect here at Crunchy Data for just shy of 5 years now. Previously to joining Crunchy Data, I ran a web app development company for 10 years using Postgres as a backend. How invited us here today to talk a bit about the database underneath AWX AAP, since Crunchy works a lot with customers on this platform. So I'm going to be giving you an overview of our Postgres operator for Kubernetes to bring high availability to the database underpinning AWX or APP. I'm going to interchange AWX and not APP, but AAP as we go along, but I'll stop saying both of them all the time. They're, as most people know, they're very interchangeable, depending on if you're commercial or not. But first, let's point out why Postgres is awesome. I mean, we love Postgres. AWX loves Postgres. Postgres is an established, reliable, and secure open source database first released over 25 years ago. It's rich, including listen, notify, rich data types, rich geospatial support, foreign data wrappers, JSON, and much more. It also has a robust extension framework. And best of all, Postgres has no central owner, so you can rest assured that it'll always live on. All this is what makes Postgres unique. And if there's anything on this slide that you've never heard of, we encourage you to go out and read more about it. As a bit of a background, who is Crunchy Data? So think of us as the red hat of Postgres. On the one hand, we are a leading contributor to Postgres. On the other hand, we have a business model like Red Hat, which consists of support subscription accompanied by consulting services for community Postgres and our HA solutions. And in addition to being a leading contributor to Postgres, Crunchy also maintains several open source components, including PostGIS, pgBackRes, and pgMonitor, for example. Let's now talk about what makes Crunchy Postgres production ready. So our solution offers high availability with automated failover and healing, backups with point-in-time recovery capabilities and write-ahead log archiving, connection scaling to easily scale to tens of thousands of connections, monitoring with dashboard and alerts, and best of all, no vendor lock-in. We offer production high availability Postgres anywhere, whether it's self-managed service on VMs or the traditional architecture, as well as in Kubernetes or OpenShift or any other flavor of Kubernetes. We also offer Postgres as a fully managed standalone service, which is on demand and pay as you go. That's now available with a connector through OpenShift as well. Furthermore, our solutions work across data centers or Kubernetes clusters or cloud providers to offer disaster recovery and resilience. We're very proud of our long-time partnership with Red Hat. We are one of the first 3 operators of any kind to be certified. That relationship has grown to the point where we are the preferred Postgres provider for flagship products like Ansible Automation Platform, Quay, and Claire. We are a Tier 1 partner certified at the highest level. Now that we got our housekeeping out of the way, let's dive into why we're here today. So I'm sure everyone has seen the AAP reference architecture, but I've simplified that a bit to what we see commonly deployed in the wild. Red Hat has done a good job increasing the availability with multiple automation controllers and execution nodes, but the database is still a single point of failure. Fortunately, we have worked closely with Red Hat and many of their customers to develop a certified operator to help you add redundancy at the Postgres database level. Here's a quick diagram showcasing our HA solutions for AWX. We see that we have primary and n number of replicas with automated failover and self-healing, backups with point-in-time recovery and write-ahead log archiving, and monitoring with alerting. We also see that we can stand up a standby cluster in another data center or Kubernetes cluster or a cloud provider to provide added redundancy and disaster recovery capabilities. So let's get right into the demo. So in this demo, we're going to see how easy it is to migrate from the standalone Postgres database to a high availability Postgres database using the Crunchy Postgres operator for Kubernetes. We will start by deploying our Postgres operator using a customized manifest, followed by a full HA Postgres cluster, also using customized. This declarative approach allows easy integration into current DevOps and GitOps processes. We will then scale down APP, migrate the data, update and the secrets, and finally scale it back up. Then, for just sort of fun of it, we're going to cause the primary to fail just to show how failover happens and recurring occurs. So let's get to it. So here, I'm going to be running this on OpenShift, but as I said before, you can be running this on straight Kubernetes or Rancher or any other flavor of Kubernetes. So here, I can show you that we do have in our operators, we do have the AAP installed here. If we look at our pods, we can see that we have our controller and we have our standalone Postgres running here. We can also see, where was the other thing I want to see in this, in the networking, there we go.
Can you increase the font a little bit?
I sure can. There we go. Is that better?
Yes, thank you very much.
No problem. So yes, we can see in the services that we have the APP controller for Postgres 13. That's the standalone Postgres. And just to show that we're not pulling any strings here, we can go in the APP controller configuration secret and show the value so that we can see the host is actually pointing to that service, the controller PT13. Also, just want to show that we have that we have a working AAP at the moment. So let's log in. So here we can see that we have a couple of organizations, a couple of users, some teams. This is just something we threw together very quickly, so there's not much information in there, but it's a functional AAP. I'm also going to be showing you guys a bit on monitoring, so we can see here that currently I have no clusters that are running. So now let's get right into installing our operator. So the first thing to install our operator is, and we're going to be doing this through, with the manifest, is we're going to start by creating a namespace for the operator itself. So here I'm going to create the namespace Postgres operator. that got created. Then I'm going to apply our operator installation customize manifest. This is our default installation. You can easily get this on our GitHub. So we're going to apply that. That's going to do the installation of our operator. We can come back here to see that we now have in our pods, we can go and see that we now have Postgres operator, and we now have our operator running. Yay. Also, if you are running on OpenShift, you can also do this, obviously, from the operator hub. So from here, you can just quickly come, do Crunchy for Postgres for Kubernetes, and install from there, and click install, and you would get your operator installed that in that fashion. So now we're gonna, I'll show you a sample of a cluster. Let me just clear that so we don't get confused. So here's the manifest for our Postgres cluster that we're going to be deploying. I'm just going to go over this very quickly. So we're saying here which image to use, which version of Postgres we're going to be installing, what's going to be the username, what's going to be the database. How did it do it like that? Showing it a bit weird there. Sorry about that. I'm showing the username, the database, the instances. So we're saying 3 replicas. So we're going to have 1 primary, 2 replicas. Our storage, I'll use the default storage, it's going to be 30 gigs. Our backup, so how are we setting up our backup? So we're giving the image for pgback rest. We're also giving its storage for pgback rest. Our monitoring, so we're setting up the exporters so that it can export the metrics so that our dashboards can pick it up. And finally, a bit of configuration for our Patroni. So how we, right now, we just made everything wide open so anyone can connect, and a bit of tuning here. So let's apply that. This will be applied in the AAP namespace because that's easier for us to see it there. But you could deploy to any other namespace. There we go. So if we come back here, we see our pods. Let's go back to the AAP namespace. And here we can see that we have our 3 replicas spinning up, and we have our repo host, which is the backrest server, repo. So we see that we already have 2 of them running. Our third one is coming up. And you can also see that it launched a backup. So when we deploy a cluster, we always recommend to have a full backup right off the bat. So this is doing the full backup here. And while that's spinning up, well, no, I actually already showed you that. So let's just wait for the backup to complete. Well, actually, while that is going, we can continue by scaling down our APP controller. So to be able to switch the database from the current standalone to the new one, we're gonna just stand down. Let me just clear that so we don't not confused. So I'm gonna scale down just so that we don't have any data loss or any issues on that front. Come back here to see that we can see that it's terminating. And we can see that our backup job has now completed. So we do have our full backup. So that's great. Let's just wait till that's gone. Perfect. So now we've scaled down. Next, what we're going to update our secret to change the automated controller database user password to match the current password. So basically, we're taking the password that was in the standalone database and we're bringing it into the new database. And we're also going to patch the APP controller, the Postgres controller. So now that we're going to change the host, we're going to now point the host towards our APP or AWX cluster, which is our HA cluster, and we're also going to change the type to unmanaged. And finally, with this, we're going to migrate the data. So we're migrating the data from the standalone, and we're bringing it over to the new HA cluster. Right, this here is using pgdump. If you had a larger database, you could set up replication, and once everything is, so you would basically replicate off of your current standalone. Everything could stay running on the standalone until things are in sync. Then you take a small outage, wait until the last little bit sync up, and then you can just promote this database and do the switch at that time. But that's something we can work with you, man, when the time comes. So now we can remove the old database. So just to make it very clear that there's no trickery here. So we're going to delete the stateful set of the Postgres 13. Then we're going to delete the PVC. And finally, we're going to delete the service. Now we're ready to scale APP back up. So we're going to just set that back to replica 1 and scale the APP controller. We can come back here. We can see that the controller is coming back up. We haven't changed anything here, but we can, while that is spinning back up, we can go and see the secret for the Postgres config, as we did before, just to make sure everything's good there. We see that the host is now our AWX cluster primary, so it's now pointing to the primary. This is a service, so our service is always pointing to the primary. So even if there's a failover or anything happens, it's always going to go to the primary. And we can also see in our services that we have this AWX primary here. And let's just go back here and see that. So this is starting back up. So while this is spinning up, let's take a few seconds just to see our dashboards that are available with our solution. So I'm just going to refresh here. We see that I now have an HA cluster that's showing up. If we had multiple clusters, because obviously with the operator you can deploy multiple clusters for multiple projects, you would see them all here. We have a lot of different dashboards that are quite interesting. So if we want to see Postgres details, for example, excuse me, we can see our active connections, our idle and transaction, our idle, our percentage to wraparound, our cache hit ratio, database size, wall size, query duration, and so on and so on. We can also see some interesting information at the pod level. This is interesting because it actually uses the C groups, so you're actually getting the accurate information. So you can see your CPU usage, your network, your CPU throttle, your disk usage, your memory, your disk activity, containers, resources, and your memory breakdown. And finally, you also have query statistics that is interesting. Not going to see much here since this is just brand new being spin up. But here you can see, this can give you good information on the runtime of your queries. You can see in red, the first one on top will always be red. It's showing you the one that ran the long. So you can then analyze this and see if it's something you can improve upon, if you can improve the queries to make it make things faster. Backrest, you also have some information on your backup. So time since last backup, your backup runtimes, your backup size, your wall stats. So that gives you a quick little overview of what we have in Grafana. I don't want to spend too much time on it because this should be up now. It does look up. So here we can come back to our APP, and I can just refresh that. And we're still, I have to log back in. I want. And we can see that I still have my teams. I still have my organizations. So we're all good here. So, and now we're running with the new database. So for the end user, completely transparent. So that was pretty cool, and that's basically it. And we now have a full HA Postgres database underpinning our AWX or APP, and it was very fast, very simple. But I also told you in the introduction that we're going to pull a little fast one on it just to show how fast things can fail over. So if we click on one of these Postgres nodes, we can see that this one is a replica. So the last one was a replica. The second to last is the master. So the second one is the master, and the first one is a replica. So let's go to the master, which was the second one, and let's say that we have a pod issue and the pod gets terminated for some reason. Well, obviously, there's a stateful set behind this. It'll spin it back up, but during the time it's spinning up, your APP would be down, right? No, it won't, because as we can see here, now the third one has become the master. It could have been the first one. I just got lucky on clicking the right one. So our third one is now the master. We come back to APP. For APP, nothing has changed. It's still pointing to the database. Everything's good. No downtime for your end users. If ever you had an in-flight transaction that would be affected, they would just need to restart it, but they don't need to reconnect or anything like that. Pretty cool. So that's pretty much it for that demo. So since we still have a little bit of time left, I thought it would be interesting to give you guys a quick little overview of Bridge. So bridges are, because in case you need to have your high availability for AWX database or any other project for that matter, but you don't want to manage it. So this is a fully managed database deployment and offering. So you can easily deploy your Postgres cluster and let us basically do all the work. So I can show you quickly, like if, so I'm already logged in, obviously. To create a cluster, very simple, click, click, click. We can come here. We just give our cluster a name. We can pick our cloud provider. It can be AWX, Azure, GCP that are available at the moment. Within each one, you have multiple regions, so you can pick something that's close by to you. So Canada Central, Montreal. It's the first time I see that one, but Montreal is definitely not central. But anyway, so let's pick that one because that's kind of funny. In your tiers, you have different tiers: hobby, so very small nodes; standard, more conventional; and memory. It's the same thing as standard, but we double up the memory. So let's take a 32 core here. You can choose which version of Postgres you want. We currently support 12, 13, 14, and 15. Let's go with the latest and greatest. You can select how much storage you need to begin with. The storage will actually increase on its own when you reach a certain threshold. So you can provision in a way that it'll scale up for you. And then you can decide if you want high availability or not for this cluster. So depending if it's a production cluster or a test cluster, you can then choose that. I'm not going to hit create here because it does take a few minutes, obviously, but I can show you one that's already been created just to give you a feel of what it'll look like once you have one deployed. So you have your cluster overview here with some good information. If ever you want to protect it, all it does is it makes sure that you can't accidentally delete this cluster while this is enabled. You see your disk usage here. You have a quick link to get your host name. You also have some data insights. So this is just an overview of data insights, which give some good information on the state and the health of your database. So here we can see your cache hit ratio, your index hit ratio, your read percentage, your row count, your size. We also see that we have a replica, so we did ask for HA on this one. And we also have many more insights. So here was the cache and index rates. That was the same thing as we saw on the first screen. Well, you also have your unused indexes. It would list here if there's any indexes that you haven't used. Your bloat, your query, outlier queries. So anything that's running too long, you can see which ones are not too long, but are running a lot. This here, you would see your long-running queries, your vacuum statistics, and your table sizes. We also have a bit of some metrics in Bridge directly. So here you can see your CPU, your IOPS, your memory, your load average, your Postgres connections. We also take backups for you, so you don't even have to think of that. So basically, what you get with Crunchy Bridge is you have a performance-tuned deployments, team management and access control, backups at no cost, monitoring 24/7, 365 by the Crunchy team, point-in-time recovery, high availability with easy configuration, a large selection of extensions, supervisor access, and much, much more. And finally, you just here, you also, this is where you can find your connection information. So depending on the format you want, this is all the information, the same information, it's just we're giving it to you in whichever format works best for you. So this is just for environment variables, which could also have the connection string for PSQL, just a URL. If you're using Rails, we also give you good information on how to get things set up for it to work on Rails, and so forth. So yeah, that's pretty much what I wanted to show you. Just a quick overview of Bridge. I don't want to spend too much time there either. Let's go back to the presentation. There we go. So, and finally, when should you consider Crunchy solutions? Well, when a single point of failure at the database level is not an option. If HA or DR is a technical requirement for you, if you require a production-ready database, or if you need 24/7, 365 support in architecture assistance. Do we have any questions?
That is a fantastic presentation, Patrick. Thank you very much.
Thank you.
I have a question. So, is it possible that for my master and backup to be scheduled to the same node? I know it's not the best thing to do, but like, is it possible?
I'm not. I didn't quite follow. What do you mean by your master and backup? To only have one pod that has your backrest installed within it?
Well, so let's say I'm not a very attentive SRE engineer, and I just plop Crunchy down with the operator on a Kubernetes cluster. I have a couple nodes, but like, is it possible for Kubernetes scheduler to decide to drop both the master pod and the backup pod on the same node?
Oh, okay. I get what you're saying. So you're talking about the same Kubernetes node. Yes, you could achieve that with. I'm trying to think of the term. Brian, what's the term? I'm sure you know it.
Yeah, so our default node scheduler is using a preferred method, which means we're going to attempt to spread it out, spread the individual Postgres instances on different worker nodes. But because it's set to preferred in the node scheduler by default, if it can't do that, it will spin them up on the same node. Through that manifest that Patrick shows you, you can set it to required. And that would prevent it from scheduling two Postgres instances on the same worker node.
All right. So in this worst case scenario, right, where my master and my backup are all on the same node, if I'm about to go, again, I'm playing the persona of unattentive SRE engineer, right? I'm about to go upgrade my Kubernetes cluster, right? So it will drain the node and do a rolling upgrade for every single one of the worker node. What happened when I hit that node where both the master and backup happen to be scheduled too? Like, is there something that Crunchy operator does to make sure, let's say, the backup gets moved to another node first before the master goes down?
Yeah, you can specify pod disruption budget that would prevent that node from being drained until X number of instances are up and running on other worker nodes.
Awesome. So pod disruption budget, is this something outside of Crunchy that we have to configure, or does the Crunchy?
No, You can configure it right in that manifest that you submit to create the cluster.
Oh, fantastic! If someone can drop me a couple lines of code or like where that is, that would be great. So tying this back to what Stanislav have helped us add to AWX Operator. Now if we use Crunchy, I think we are able to achieve a zero outage upgrade of the underlying Kubernetes cluster when we like for AWX and AAP. So I'm looking forward to trying out Crunchy with AWX and try out this rolling upgrade scenario.
Yes, but for that scenario, I would definitely leave things to the preferred, that your node is at the preferred level. And that way, when you do drain the node, it will be able to bring it back up on a separate node. If you set it to required, then you're telling it, no, you have to be installed on that node. And if that one goes down, it can't do anything. But if you're preferred, then it'll move automatically through Kubernetes to another node.
Perfect. So I have some question around failovers. What is the expected recovery time for the failover?
Well, as you see, it's pretty much instant. So your replicas are pretty much always up to date. As soon as the framework and our operator sees that there's an issue, so actually the failover part is not even controlled by our operator. It's controlled by a framework that's on the pod itself. So the pod is able to communicate with the other pods, the other Postgres pods, and as soon as there's an issue, it will automatically launch an election and move the master to or the primary to a new node. As you saw, it was very fast. And that's not because I had little data or more data or anything. It's not data related. It's just very fast. It'll detect it and move over. So there's really there's very little downtime. And if AWX were to change a bit the way it works, so that if ever there's a failed task that it retries, more than likely, it probably won't retry more than once, and it'll be able to work the second time, basically. So if you make that change and you're still with your standalone Postgres, if your standalone Postgres goes down, obviously you're going to do 2, 3, 4, 5 retries, and then decide to give your error, saying that you've lost connection to your database. If you are underpinned on a Crunchy HA cluster, then you'll try once, maybe twice, and it'll go through because the failover will have happened already. And as soon as it happens, you're now accessing a writable database, and the task will proceed.
Awesome! I'm really looking forward to trying out Crunchy data with AWX. Alan have some question regarding PG notify during failover. Alan?
No, we need to test it with this, and we haven't gotten around to doing that in like our kind of traditional deployments are a little bit too much. But I think that basically the first way we're going to be able to test it is to use these things that you're presenting on here, that's unambiguously, I think, the easiest way to do this. We just need to get some systems and run the failover and then test that things are working, because the scenario is a little bit less obvious than it seems, because you absolutely, you come and you create a new connection and it's going to work great. We have something that's listening on listening for data from PG notify, and the concern is that it's listening, but the listening isn't working anymore, and that might be a lower level problem with how we're doing it, and the select in Python itself. So that's the speculation. There's an issue and quite a lot of information from a community member about it. I'm trying to. I don't fully follow it. I have more questions about it, I think that we're just going to have to do it at some point.
Yeah, Alan, to answer your question, existing connections, when that failover occurs, they would be disconnected and would need to, the app would need to reestablish. Now, the one thing we haven't tested yet with AAP is leveraging PG Bouncer, which is there, can be there. The operator can create a PG Bouncer instance. I know traditionally that hasn't worked well with Tower, but we have not tested it yet with AAP.
I see. Yeah, it sounds like the issue that we had is a form of it gets disconnected, but it doesn't know that it got disconnected. So if we get disconnected, we're fine with that, right? We know exactly what to do, but then we don't run down that code path. So then you have a process that's like stuck, not knowing that it got disconnected is the kind of problem.
Yeah. Yeah, PG Bouncer, it's a connection pooler that could potentially mask that failover, except for it would mask the connection, reestablishing the connection. Any active session doing something when the failover occurred would obviously get an error message back, but at least they wouldn't have to think about the connection. But there is some caveats there. We need to test that with AAP. Tower was not compatible with PG Bouncer for whatever reason.
Do we have any sixth sense about why, or do we have any historical information about why we don't work well with PG Bouncer? Alan, John, Christian?
I can link you the pull request where there's some speculation. I know it's gone a little bit still. I haven't responded to it yet because I'm not following all the way up to where this community member got. So I'll link that in the chat in 1 second.
Non-user had a couple of questions in the chat. There was an older one. We probably lost context around this, but is that done with pod node affinity? I believe we were talking, that was then when how you were talking about like the master and the replica running on the same node.
Yes, it is.
And then they also asked, so all the running jobs during a failover will be dropped. Is that correct?
I don't think so. Currently, well, from what Patrick and Brian have told us, we will lose connection. Well, there are a chance that like there's a short disruption to our connectivity to the database, but if in our code we retry hard enough, well, doesn't even seem like we have to retry that much, right? But if we make sure that everywhere we are trying to communicate with the database, we have a retry, then we should be able to tolerate the failover event. So to answer the original question, no, I don't think the job will ongoing automation jobs will fail or should fail. So this is something that we will try to focus on.
My problem initially was that I've tested with that on AWS, and when my instance, for example, gets full with jobs, and if I don't set port affinity, and it tries to move the AWX from the initial instance on the new one, and it kills all the jobs and everything until the new instance is started from AWS. That's why I'm asking, and that's why I'm always working with node affinity, because yeah, until my recent recollection, it always moved the Postgres port around the open. Actually, yeah, the operator and the AWX also put with the fork containers with the execution environment, and those they were also moved to the new instance. And yeah,
I think what your experience is probably out of memory killed from Kubernetes. Like if you have a lot of job
yes.
in the AWX schedule
Yes.
on the same node. Yeah.
Yes, that's correct. Because during update, I'm starting like 150 jobs, and most of the time, if I haven't manually scaled my AWX node group to 3 nodes, and initially it's just one node group, and just because of that, there is no enough place for all the jobs to be started. That's why it's if I leave it on the autoscaler, it's killing the as I said, the Postgres container, the operator, and the AWX task containers, the web interface, and all of them. And yeah, you just get dropped off all the jobs, and you just when the new instance from AWS is there, you just start the whole process again, and it just works. But yeah, during this downtime until you're waiting for a new instance without node affinity, yeah, you're out of luck.
One way of eliminating this problem for you will be to separate your AWX control plane from the execution plane. So basically, creating container groups on an external cluster will end up isolating your jobs to a whole nother cluster, so that you don't have to worry about your control plane pod being rescheduled due to job pod taking up all the CPU and memory.
Yeah, that I haven't tested.
And recently, I know that you move to external. Yeah, which definitely helps here. But you will still run into a problem where your AWX control plane gets out of memory killed. So separate, like if you run high enough jobs, I would recommend to separate your control plane from your data plane. Sorry, control plane from your execution plane.
Yeah, gotcha.
Any other question for the fine people at Crunchy?
I was just going to mention that I noticed that there was a need to patch the Postgres secret. That is something that we're actually going to work on fixing on our side to make this integration even better going forward. And I mean, you demonstrated a perfectly fine way to handle that. But hopefully going forward, we can make that even easier. So I just want to thank y'all for this presentation. It was awesome. Great information all around.
Yeah, I'm just excited about trying it out now.
Pleasure.
Oh, before we go, I have one question. So can we just deploy Crunchy to try it out without having to ask my manager for more money?
Well, we always like you to ask your manager for more money, but yes, you can. The operator is available in our GitHub. Elizabeth put a link there on the quick start guide, so you can look at it there. And you have the developer portal where you'll be able to get something so that you can test it out.
Fantastic. Thank you very much. Just one more thing before I stop. That monitoring database. That monitoring dashboard. That looks awesome.
It is.
I can't wait to try that out.
It's a project that we actually maintain at Crunchy, so it's something that we're always fine tuning and improving. So yes, it's definitely something that we have available to all our products.
And I think it's also open source. I think anyone can monitor with Postgres, whether you use the operator or not, right? Like you can just run it as a sidecar to Postgres, I think.
Absolutely.
Okay.
Nice. Okay, cool. I see someone flashed it on the screen. The next question is, how do we engage with the Postgres and Crunchy community?
Yeah, so as I had posted a page of links, even if the links you couldn't actually, obviously you're not going to be able to click on them, but we will post the different links on as comments in the YouTube video once the YouTube video goes up. And you guys have also shared another slide here showing some of the links. And also just wanted to point out that we're going to be at Red Hat Summit also in May. So if any of you are around, we'll be happy to meet you there.
And we're also pretty collaborative from a community perspective. So if you have questions about the operator, we have people to answer the mailing list. And, if you want to talk to someone at Crunchy about different things, just shoot us a contact us note and somebody will get back to you.
Thank you all so much. So since we mess up the meeting today, a couple of us will stay for a little bit longer for community member that stream in at the correct time. But I think we can stop the recording from here, John.
I think we just had a couple more slides.
Okay.
Before we stop the recording.
I will edit this part out.
The contributor thanks. We just wanted to thank our first-time contributors to both AWX and Operator. And again, another thanks to Phillips T6 for the nice contribution that allows complex extra bar injection. Okay, so that would be everything then. Thanks to everyone who attended, and again, our apologies for messing up with the time zone. We will make sure that's remediated so it doesn't ever happen again. And with that, I'm going to stop the recording.